Now, a piecewise function is a function that has different equations that represent specific intervals of the x values. So here we see that this function has a value of 6 from negative infinity leading up to negative 2. And from negative 2 to positive 2, it has a different expression representing the function. And from positive 2 to positive infinity, it has a third expression representing the function. Now what this means for sketching a piecewise function is graphing piecewise functions requires creating a table of values for each interval of the x values. So starting with the first interval, we'll need to plot points from negative infinity up to negative 2. So we'll use 3 points for this part of the interval. Between negative 2 and positive 2, we'll use 3 or 4 points to help sketch this portion. And then lastly, we'll use 3 points to sketch the third part of this function, x plus 5. Now, something to keep in mind, you'll see here at the end of each interval, you either have a filled in circle or an empty circle. This is because of the fact that the expression that includes or equal to includes the value at the limit, while the expression without it does not. So here we see that x is less than or equal to negative 2. So since x can equal negative 2, the first interval has a circle that's filled in, but the second interval is empty since this is x is greater than negative 2, but it is not equal to negative 2. Only one of them can have this equal sign. The function can't be equal to both, or else it would have two y values affiliated with that one x, and then it would not be a function. Same thing with this part of our function at positive 2. Here we have x is less than or equal to 2. So the second interval has the circle that's filled in. Since when x is equal to 2, it is a part of the second interval, not the third interval. The third interval is x is greater than 2. So it is every point after 2, but not 2 itself. Okay, so pay very close attention to the or equal to sign as it will affect your resulting graph. So let's walk through an example together. Let's say you're asked to sketch f of x is equal to 6 if x is less than or equal to negative 2. F of x is equal to x squared if negative 2 is less than x, which is less than or equal to positive 2. And f of x is equal to x plus 5 if x is greater than 2. So this is the piecewise function we just saw, but now we will sketch it from scratch. So how do we do so? Step 1, evaluate the first interval of f of x with 3 different values. So this will be pretty simple since the function has a consistent value of 6. So since we're leading up to the point of negative 2, we can use negative 2, negative 3, and negative 4. We're getting more negative. And for each corresponding y value, it is 6 for each one. Since no matter what, when x is less than or equal to negative 2, the function will be equal to 6. So each output will be 6. And now step 3, evaluate the second interval of f of x with 3 different values. So we have x squared if negative 2 is less than x, which is less than or equal to 2. So I always like to use the limits so we can see what is happening at the limits. So we plug in negative 2 for x, we get f of negative 2 is equal to negative 2 squared, which shows us that f of negative 2 is equal to 4. We can then go to the middle. 0 would be halfway between negative 2 and positive 2. So when we plug in 0 for x, we get f of 0 is equal to 0 squared, which is 0. So the input is 0 and the output is 0. And then we want to plug in positive 2 for x, showing us f of 2 is equal to 2 squared, which is 4. So the input is 2 and the output is 4. So this is the second table of values that we use for the second interval. And we need a third table of values for the third interval, x plus 5. So we want to evaluate the third interval of f of x with 3 different values, and then record the input and output values from step 5 in a table of values. When we do so, we'll plug in 2, which is at the limit. F of 2 is equal to 2 plus 5, which shows us f of 2 is equal to 7. Now, although this particular point is not included in the third interval, this helps us understand where we should be placing the empty circle for this interval. So that is why I use 2 here, even though 2 is not included in this specific interval. It's so we know where to put the circle. The next point we'll plug in is 3 for x, showing us f of 3 is equal to 3 plus 5, which is 8. So our input is 3 and our output is 8. And the third point, we'll plug in 4 for x, showing us f of 4 is equal to 4 plus 5, which is 9. So the input is 4 and the output is 9. So now that we have the table of values for each interval of this function, step 7 is to plot the points for each interval of the function on a coordinate plane. So we'll start with our first table of values. In the first interval, it has a consistent value of 6 when x was equal to or less than -2. So our first 3 points are -4, positive 6, -3, positive 6, and -2 and positive 6. And then we draw a line through the points. So this will be our first interval here. And now we take a look at the second table of values. The first point is -2, positive 4. The second point is 0, 0. And the third point is 2, positive 4. And now that we've plotted the points, we can draw a line through those points. And now for the third interval, the first point is 2, 7. The second point is 3, 8. And the third point is 4, 9. And now with these 3 points, we can draw a line through the points to give us a sketch of that interval as well. And now that we have a sketch for all 3 intervals of this piecewise function, we want to take a look at the less than and greater than signs in the piecewise function to help us determine what types of circles we should add to the ends of each interval. So step 9, place a filled circle at the end of the first interval where x is equal to -2. This is because here it is x is less than or equal to -2. So at -2 along the x-axis, it is the first interval that has a filled circle. So since this one is filled, that means for step 10, we want to place an empty circle at the end of the second interval where x is equal to -2. So at -2, the function has a value of 6 here, and it does not have a value for the second interval at exactly -2, but it does for each point after that. And now at the other end of the second interval, we want to place a filled circle where x is equal to +2. Here, in the second interval, we have x is less than or equal to. Since it can be equal to 2, at 2, the circle is filled, which means for the next circle, where x is equal to 2 for the third interval, we're going to place an empty circle, since x is greater than but not equal to 2. And once we have that, we have now completed the sketch for the piecewise function. So that is how we go about graphing a piecewise function. Let's now have you complete a practice question. Sketch f of x is equal to x minus 2 if x is less than or equal to -3. F of x is equal to x squared plus 3 if -3 is less than x, which is less than 3. And f of x is equal to -4 if x is greater than or equal to +3. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, evaluate the first interval of f of x with 3 different values. So we have f of x is equal to x minus 2 if x is less than or equal to negative 3. So we'll start where x is equal to negative 3, and then we'll proceed to points that are smaller than negative 3. So we'll use negative 3, negative 4, and negative 5 in the first table of values. So when we evaluate f of negative 3, we want to plug in negative 3 for x here. So we get f of negative 3 is equal to negative 3 minus 2, which is equal to negative 5. So the first row in this table of values is x is negative 3 and y is negative 5. We then want to evaluate f of negative 4, which would be equal to negative 4 minus 2, which is equal to negative 6. So the entry would be negative 4, negative 6. And then the third row would be f of negative 5, which is equal to negative 5 minus 2, which is equal to negative 7. So the input value would be negative 5 and the output value would be negative 7. And now that we have 3 points from this interval of the piecewise function, we can now work on the second table of values by evaluating the second interval of f of x with 3 different values. And then we will record the input and output values in a table of values. So when we evaluate f of negative 3, f of negative 3 is equal to negative 3 squared, which is 9, plus 3, which is equal to 12. So our input is negative 3 and our output is 12. We can then plug in 0 for x. F of 0 is equal to 0 squared, which is 0, plus 3 would be 3. So the input is 0 and the output is 3. And then for f of 3, we get f of 3 is equal to 3 squared, which is 9, plus 3 would be 12. So the input value is 3 and the output value is 12. And now that we have 3 points for the second interval, we can now work on the third interval. So step 5, evaluate the third interval of f of x with 3 different values. And then step 6, record the input and output values in a table of values. For this one, the interval always has a value of negative 4 if x is greater than or equal to 3. So when x is 3, 4, 5, or any larger number, the value of the function, or the y value, is consistently negative 4. So this is the table of values for our third interval. And now that we have the 3 table of values, step 7 is to plot the points for each interval of the function on a coordinate plane. So starting with the first table of values, our first point is negative 3, negative 5. Our second point is negative 4, negative 6. And our third point is negative 5, negative 7. And now that we have 3 points that we can use, we can sketch this section of the function by drawing a line through these points. And this would continue for x is negative infinity. And also y, it would head towards negative infinity for y. And now we can begin sketching the second interval. The first point was negative 3, 12. The second point was 0, 3. And the third point was 3, 12. And with these 3 points, we can now sketch the second section of the function by drawing a line through those points. And now for the third interval, the first point is 3, negative 4. The second point is 4, negative 4. And the third point is 5, negative 4. And now we can sketch the third interval of this piecewise by drawing a line through the points. And now we can complete this sketch by adding these circles to the ends of each interval. So for step 9, we want to place a filled circle at the end of the first interval where x is equal to negative 3. The circle is filled since in the first interval, x is less than or equal to. So since it can equal -3, we need to fill the circle to indicate that number is included. Step 10, place an empty circle at the end of the second interval where x is equal to -3. It is empty since x is greater than but not equal to -3. So -3 is not included. And now step 11, place an empty circle at the end of the second interval where x is equal to 3. It is empty since x is less than 3 but is not equal to 3, so that number is not included in the second interval. And finally, step 12, place a filled circle at the end of the third interval where x is equal to +3. And it is filled since x is greater than or equal to. So since it can equal 3, that number is included, so the circle is filled. And with that, this would be the answer to question number 1.